Lesson 28, average speed. We will be able to describe the difference between average and instantaneous speed. I am writing on the screen now. If you can't see that, it's because I'm not sharing it to let me know. Otherwise, I'm just going to keep going. So what are these two words? We've talked about what speed is. What was speed? Let's get a quick reminder. We talked about motion. We started off by saying distance and displacement. We said displacement is all about not just how far you've gone, but displacement is also about which way you went. It's a vector quantity because it has direction, whereas distance is scalar. Speed, on the other hand, speed is a scalar quantity. It is the distance traveled over time taken. We just did an example of that. We can use different units. Usually use kilometers an hour, meters and seconds, and centimeters per minute. But you can use different versions of them. And we also talked about how to convert from one to another. We did some examples where we calculated speed. And then what we did was we looked at units. We said, hey, if you've got 60 kilometers in 1 hour, you can convert kilometers to meters and hours to seconds, and then bish bash, you're done. You can, of course, use this rule by multiplying by 3.6 or dividing by 3.6. I think if you go from, but don't quote me on this, to go from kilometers an hour to meters per second, I think you divide by 3.6, but I don't remember exactly. Please don't take my word for it exactly. I might be wrong here. Now, we talked about changing the formula. You can take velocity equals distance over time. I actually thought about making this the attendance question, but I didn't. You can quickly turn that into time. You can go VT equals the distance. If you're traveling at 20 kilometers an hour for 2 hours, you can use that to find out how much far you've traveled. And then what I would do, the other one would be, of course, to say T equals D divided by V. Now, I actually used to do this. In the car a lot like when I was really bored. I'm not sure if you guys have been on those road trips where it's like, oh my God, this is so boring. And what you would do on those big road trips, what you would see is you would see a sign, and the sign would be like this. You'd be on the freeway, and the sign would be like this. And usually these signs are green, and it would say something like, I don't know, let's just say Melbourne. Sorry. Why? You guys can't see that. I'm going to go back to black. Say Melbourne, and it would say, oh, Melbourne is 63 away. And so you go, okay, 63 kilometers. And then I would actually try to do my maths in the head. I'd say, well, 63 kilometers. We're going 100 kilometers an hour. And then I go, well, let's just call that 60 kilometers. So let's go 60 divided by 100. And I go, well, that's about 0.6. 0.6 hours. That's about 36 minutes-ish. And then I would see if it took about 36 minutes. I was a massive nerd as a kid. Please don't judge me too hard. Velocity was the last one we talked about. Velocity is the upgraded version of speed. It has a displacement over time, which means it has a vector, which means you need to include a direction. This is new, by the way. I added this to the slide. You can write this down. You can look at it later on, but I will quickly talk about it now. You can talk about velocity as having a direction, but just using positive and negative. I don't know why I switched between them. That should be a plus and a minus, doesn't matter. But for example, let's just say that you say up is positive, and you say, well, I threw a ball up, and after 2 seconds, the ball's velocity was -2 meters per second. That means the ball is going down. Because you've said up is positive, negative must be down. You could say, oh, it's going +5 meters per second. That means it's going up in the air. But you have to define your direction at the start. But yeah, I don't expect you guys to write that down now because I'm just talking about it. But if you want to maybe go back later on and add that to your lesson from last lesson, you can. I might even put this up at the very end of the lesson, so you can do that. We then talked about displacement versus speed versus velocity, and displacement versus distance, and which one and how to talk about it. But honestly, the answer is this: it doesn't matter how you get from point A to point B. You can go this way, you can go this way, you can go, you know, some crazy route here. Your displacement is the same. So your velocity is going to depend on just how quickly it is you took to do that. It might be, sometimes you'll find that it's faster to take a route that goes around than it is to take the direct route. And that's fine, but you sometimes might mean that your velocity is the same. Okay. Then what I did for homework is I said you needed to do this. So the rest of this lesson, I'm going to give you guys time to work on questions 5 to 8. But before I do that, I want to teach you guys what average speed is. Average speed equals the distance traveled divided by the time of travel. So the average speed is the total distance divided by the time. So, and this is very, very similar to the example that I did before with the Geelong question. What that means is that if you take the average distance, let's take this distance here. This is from Melbourne to Mildura. Melbourne to Mildura is actually where is this? 548 kilometers. Okay, so if you take 548 kilometers and you divide that by the time it takes to do that, which is 6 hours, that will give you an average speed, which is 91 kilometers per hour. Now, here's something that's really actually pretty important here, ladies and gents. This is an average speed. And I think you guys actually figured this out from last lesson. I was actually really proud because sometimes my year 10 engineering math students don't get this idea. Average speed, right, is the average of all of your speeds. That means that you're probably not going to be spending much time traveling at 91 kilometers per hour. Most of the time, you're probably going to be traveling faster than that, 100 kilometers an hour. But the reason that your average speed is in 100 kilometers an hour is because you still spend some time going less than 100 kilometers an hour. Average means that it's kind of like saying the average amount of children in a house in Australian households is 1.8. That doesn't mean that there are like millions upon millions of houses have 1.8 children. It just means most houses have 2 children, and a couple of houses have 1 child. This doesn't mean that you're traveling 91 kilometers an hour. It means that most of the time you're traveling 100 kilometers an hour, and some of the time you're traveling 60 kilometers an hour, or you're stopped 0 kilometers an hour. So just keep that in mind when we look at average speed. Can I change the slide? Are we cool?
Yeah, you can change it.
I can change it? Cool, thank you. Man, my volume is really low. That's probably why I couldn't hear you guys before. Okay, so I just pumped up the volume, so cool. So we're going to do a bit of an example. We're going to do a bit of a hiking example. Now, I want you guys to pay attention to the values that happen in this one. A man walked 3 kilometers up a hill in 20 minutes. He stopped for breath for 10 minutes because probably it was a pretty steep hill, so probably needed a break. And then he walked 4 kilometers for 30 minutes. What is his average speed? Well, let's do this. Average speed equals the distance traveled over the time taken. Okay, so let's figure out how far he traveled. The total distance is he traveled 3 kilometers up a hill. He didn't travel all of this part, and then he traveled 4 kilometers. So that means his total distance traveled is 7 kilometers. What about the time? He took 20 minutes there to walk up the hill. He took a 10-minute break, and then he took 30 minutes to walk up to walk that 4 kilometers. If we add those together, it's going to be 60 minutes or 1 hour. So 7 kilometers divided by 1 hour means he's going a speed of 7 kilometers per hour. And that's all you have to do. Now I've started to do this as part of my lessons because, as I said, I've had the ability to teach this in engineering maths. A lot of students forget this. They think, oh, well, he's not moving, so therefore I shouldn't add that in the average speed. But you most certainly should, because it's still the average speed is the total distance traveled in the total time taken, right? You're not talking about how quickly he's walking, you're talking about how long it takes him to complete that journey. And so if he spends 10 minutes resting, then that's still part of the journey, that's still part of his average speed. So that's how you would calculate that for average speed. Do I need to explain anything more with this, or can I change the slide, or do you guys need a second to copy this down? If Brendan, you say you need to copy this down, yes you do, there's a pencil on the top left corner.
Did you say my name?
What? No, I didn't say your name. Have you copied it down though, Brendan?
Yeah.
Of course, yeah. Cool. Is everyone else, are we good to move on? Yeah? All right, so I'm going to move on. Unless someone stops me, I'm going to move on. So this is what we call average speed. The average speed is you take the average of all of these speeds. But there is something else that we could talk about here. Average speed is how fast you're going overall. The opposite of average speed is instantaneous speed. Now, instantaneous speed is the exact speed that you're going at a particular time. So, I'd like you to write this down. Instantaneous speed. This is the speed at a split second. So, if we were to look at the man as he was hiking, the instantaneous speed would be this, like if you were to look at him and say, well, how far did you travel in that first section? That speed would be his instantaneous speed, not the overall average speed. How fast is he going at that one time? If we were to look at our journey from Melbourne to Mildura, the city, we said that the average speed was 91 kilometers per hour. But if we were to look at the speedometer exactly 1 hour and 15 minutes into the trip, and it's at 100 kilometers an hour, that would be an instantaneous speed. The reason we use the word instantaneous is it means in an instant, right now. That's when it's happening. There are some ways that you can use that. You can use the gradient at a specific point on a position time graph, which I haven't taught you what a position time graph is. Don't be afraid that you guys haven't learned that yet. Or you could just use, again, the formula V equals D over T. You can just use that formula to find out how fast they were going at that particular time. So for the per people hiking, right? Actually, I'll jump back. The people hiking for, give me 1 second, sorry, 3 kilometers in 20 minutes. They traveled 3 kilometers in 20 minutes. You don't have to get this copied down. 3 kilometers in 20 minutes. 20 minutes is 0.33 hours. If you, which means they were going 9 kilometers per hour. Now, that's going to be the, that 9 kilometers an hour is an instantaneous speed, because that's how fast they were going at that point. That's not the average speed. That's the speed that we're going at that time. So it's an instant. So you can use both of those to work it out. You don't need to write that down. I just wanted to put that there so you can see, yeah, you could just use V equals d over t. And that's the difference between those two things. And knowing when you're to use instantaneous speed and when to use average speed is important. And knowing what they are, how they're different is also pretty important too. They have advantages and disadvantages. I think we're going to spend more time using instantaneous speed than average speed. But yeah, just so you know, that's what the difference is. Ladies and gents, that's all I had to explain to you guys today.